With energy costs rocketing in the 1970s and 80s, building designers and operators rearranged their priorities. Outside air was now to be kept outside. An open window represented a heat loss, so more and more buildings were now to be designed as airtight envelopes. And this coincided with two other fundamental changes over those same 20 years. An increased reliance on synthetic building and furnishing materials, along with an increase in the number of hours people were spending indoors, amounting, in fact, to more than 90% of their time spent at home, at work, or in some form of transportation between the two. No wonder, then, that we're forced to pay more attention today to the quality of our indoor air. In fact, we ourselves are affecting this quality all the time, with substances from cleaning agents, waxes and solvents, from particle board, wall coverings, paint, foam, carpets, vinyl and rubber flooring, disinfectants and room fresheners, and dozens of other elements that go into the construction and furnishing of a building. And by our activities such as copying, printing, duplicating, cooking, cleaning, and simply by living and breathing. For we ourselves are constantly giving off bacteria and skin scales, carbon dioxide, and fumes from dry cleaning, deodorants, perfumes, and hairsprays. Then tobacco smoke, too, is seen by many people as a contributor to the mix. However, it's interesting to note the findings of several major studies on this point. More than 50% of the buildings investigated had inadequate or poor ventilation systems, whereas in only 2 to 4% of cases in which building occupants complained of sick building syndrome were the complaints ultimately associated with tobacco smoke. And if ventilation and air filtration are inadequate, it follows that those substances, many of which can cause discomfort, will not be adequately removed or diluted. And if air conditioning units are badly designed or maintained as well, stagnant water may collect, in which microorganisms can flourish. Then the very air handling system which is meant to provide fresh air may also be delivering bacteria and fungal spores. However, a well-designed and maintained HVAC system is integral to providing acceptable indoor air quality. A conventional HVAC system introduces the air, usually at ceiling level, heated, cooled, humidified, or dehumidified, as required to mix with the air already in the room. Used air is then exhausted through ceiling grills. An interesting alternative to this, used for some years in Scandinavia and Europe, and in U.S. industry as well, is the displacement ventilation method, which introduces air at the base of the walls or up through the floor. As air rises, it speeds the natural upward flow of the warmed air already in the room, and is then exhausted through ceiling grills. This was the technology Philip Morris engineers used in 1990 to develop the FACT system, Filtered Air Control Technology. FACT combines existing HVAC technologies and components to supply an even upward flow of filtered air, which can improve air quality in a variety of situations. It has proven effective in high-density smoking environments. With FACT, the used air can be exhausted directly outside or else partially recirculated, mixing with new air from outside, passing through an electronic air cleaner which removes most particulates, then through an acid-treated activated carbon filter to remove gaseous components. Then the filtered air passes over heating and cooling coils and is sped by a constant volume blower into a main supply air duct, then through smaller branch ducts in the underfloor plenum and up through perforations in the raised steel floor. The floor is covered with standard commercial-grade woven carpet, but with its backing modified to allow air to flow through it. And a simple test with a sheet of paper shows just how well it flows, providing a cushion of air on which the paper floats easily. Since the air is supplied at 68 degrees, FACT does not create any sensation of draft on ankles and legs. Its flow rate can be adjusted to a room's occupancy and use, and can change its air completely in 2 to 4 minutes. This means that the airborne substances by which we affect our indoor environment, dust, dirt, skin scales, tobacco smoke, bacteria, and so on, will rise vertically above the room occupants and be removed into the exhaust located in the ceiling. Since most emissions from human activity are usually warmer than the surrounding air, they'll naturally move upwards on thermal currents. The upward flow of the FACT system simply speeds up that process. To show how the FACT system performed against the realities of commercial use, it was installed in a 660 square foot patron lounge as part of the renovation of the Benedum Center for Performing Arts in Pittsburgh, Pennsylvania. The lounge is used for intermission refreshments and accommodates both smokers and non-smokers. This application employs an air handling system which recycles 50% of the room air, mixes it with new outside air prior to filtration. Then a constant volume of treated air moves upwards through the lounge at a rate of 10 feet per minute, so that the room air is completely replaced every 2 minutes. To evaluate the system, air samples were taken outside the building, in the lobby next to the lounge, at floor level, breathing zone level, and ceiling level at the front, center, and rear of the lounge during various periods when it was in use. The results reported here were from the samples taken at the center of the lounge, at breathing zone level, and the occupancy periods were with 2 people present not smoking, 25 people present not smoking, 33 people, most smoking, an extremely high smoking density here, with 44 cigarettes and 2 cigars being smoked in total, and finally with 3 people left after everyone else had gone, now with no smoking. The team measured temperature, relative humidity, fine dust called respirable suspended particles, formaldehyde, nicotine, carbon monoxide, carbon dioxide, and microbial counts. Temperatures in the room ranged from 67.8 to 72.6 degrees Fahrenheit. Relative humidity readings inside were maintained between 42 and 48.5%. RSPs were 50 micrograms per cubic meter in the outside air and much lower in the lounge. The formaldehyde levels were consistently below the minimum detection limit of 0.03 parts per million. Nicotine was less than 0.66 micrograms per cubic meter in every sample taken, except in the high-density smoking period when it was 13.6, and the final period when it fell back down to 0.80 within minutes of the lounge being emptied. Carbon monoxide measured 2 parts per million throughout the trial, except for the period of high smoking activity, when it increased to 3 parts per million. Not surprisingly, the CO2 levels changed in line with the number of people present, starting at 350 parts per million, peaking at 500 when the room was crowded, and falling to 400 when it emptied. Colony-forming units of microorganisms ranged from a high of 701 in the outside air down to 96 in the lounge. No pathogenic organisms were found. This has been the story of just one fact success. There will be more, for the possibilities of this remarkable development are endless. For conference rooms, airport and train terminal lounges, shopping malls, restaurants, museums, theaters, movie houses, and designated smoking areas. We're using energy-efficient techniques in designing our buildings, more synthetics to construct and furnish them. We're reducing the amount of air to ventilate them, and then we're spending a whole lot more of our lives in them. So really, effective ventilation becomes more and more important. And that's why we are constantly evaluating new products and technologies, seeking out new ways to improve the quality of our indoor air.
If you'd like to be kept informed of these developments, or if you'd like more details on the FACT system, call toll-free in the United States, 1-800-998-FACT.
The system is working fine for us, and we're very pleased with it, and so are our patrons. They find this atmosphere very comfortable and enjoy being in this environment, and when they come to performances, they look for the space and do spend time here.